Alright, welcome. Today we are going to be doing 1.8. So 1.8 is perimeter, circumference, and area. So this should be a review from previous years. So really important formulas that we're going to need to know and understand. Alright, so let's get into it. We have perimeter is the sum of the lengths of its sides. So especially when you get into rectangles and squares, we just add up each of the sides. Area is the number of square unit it encloses. So when we think about perimeter is like the outside, and when we think about the area is like the inside, and we measure it by square units. So we don't need to write those definitions down, but what we do need to write down those, we need to write down all this right here. So all this right here, yep. So what we have right here is the perimeter of a square is you add up all four sides, or 4s, 4 times each side. We have the area equals side squared, or side times side. For our triangle, important formula that we're going to need to know that when we take the perimeter, again we're just adding up each of the sides, a plus b plus c. And then for the area, it's going to be base times height divided by 2. So you don't need to draw this right here, but if I were to draw it, I would see that this right here is a rectangle, and so the area for a rectangle we'll see is base times height. So for a triangle, we're just going to take away half of that. So make sure that we have that formula written down. For a rectangle, since we have 2 of the sides are congruent, we can either do 2b plus 2h, or we could just add up all the sides together in order to find out the perimeter. But we remember that each of the sides are congruent, and remember that's why we have those lines right there telling us that side is congruent with that side, and this side is congruent with this side. To find the area is just base times height. And then finally for a circle, the circumference, remember circumference for a circle means the outside, which is the perimeter for a circle, and it is pi times diameter. And then remember diameter is all the way across, or we could do 2 times pi times radius. Radius is halfway, which 2 radius equals 1 diameter. So it's the same thing. Doesn't matter which one you use in order to find circumference. But area equals pi r squared. So r times r, radius times radius. Okay? Make sure we have that all written down. Alright, next let's go to our first problem that we have right here. So we're going to write problem number 1. Whoops. We're going to write problem number, lose control. Problem number 1. Problem number 1 right here. Alright, you want a picture frame that is 5 by 7 with a 1-inch frame. What is the perimeter of the picture? Okay, so whenever we get to problems like this, it's always really helpful to draw pictures that go along with it. So let's draw it right here. It says we have a picture, and it is going to be 5 by 7. So if I draw that right there, and I have, this is going to be 5 inches, and this is by 7. And A says what is the perimeter. So remember, perimeter is just the outside. So I have right here, remember the 2 sides are congruent. So we have this top side right here is going to be congruent with this side, which means that if the top is 5, then the bottom right here is going to be 5. And I'll use my congruent signs as well for the sides. Whereas if this is 7, then this side is going to be 7. So to find the perimeter, we're just going to take the perimeter right here is each of these sides added together. So I have 5 plus 5 plus 7 plus 7. So my perimeter equals 10 plus 14, and that is going to give me 24 inches. And we just label it as inches. We don't cube it because it's not area. Alright, so B now. B says, what is the perimeter of the outside of the frame? So remember, in the beginning of the problem, it said that there was a frame and it was 1 inches around. So I'm going to use, let's use a different color right here. Let's go orange. So I have 1 inch right here, 1 inch on the outside. Okay, went back to red. I have 1 inch right here on the outside of the picture frame. Okay, so it means that I am adding an extra inch right here on this side and an extra inch right here on this side. So my total length right here is going to be 9. If I have an inch up here and an inch down here, 2 extra inches plus that is going to be 9. The same thing for the bottom right here, where if I add an extra 2 inches to the side, an inch right here, an inch right there, those 2 inches added together with 5 is going to be 7. So when I take the perimeter right here, and I have the top, which is 7, and the bottom, which is 7, the same thing, and then I add it with the 2 sides, 9 plus 9, that's going to give me perimeter equals 14 plus 18. 14 plus 18 is going to be 32, and we're going to label it inches, and again, we don't square it with perimeter. So again, really helpful to draw pictures. Pictures to help. Alright, next, let's go to problem number 2 right here. Problem number 2. And it says, what is the circumference of a circle in terms of pi? So make sure we write number 2, that we draw, that we write out the question, and we have the picture as well. So it says, what is the circumference of a circle in terms of pi? So we need to remember our formula is circumference equals pi times diameter, right? Pi times diameter. And look, we are given the diameter right here. So circumference equals 15 times pi. So a lot of times we can just leave it right here as we put the number in front of pi. So that would be our answer, 15 times pi. And it says, what is the circumference of the circle to the nearest tenth? So we can plug this into our calculators. Most times our calculator will have a pi button, or we know that pi equals 3.14. So we take that 15 times 3.14, and that is going to give us 47.12, and so I'm just going to round it right there to the 10th, 47.1. And in both of these cases, we need to label it. We're going to label it inches, and this is going to be inches as well right here, inches. Remember, circumference is like the perimeter of the circle. Alright, on to the next one. Alright, problem number 3 right here. Problem number 3. And it says, what is the perimeter of EFG right here, EFG, and we have a picture over here, so make sure that we draw out the picture as well. And so what we do is we remember from our last lesson that we could use the distance formula to find each of the sides right here. But if we're looking at a coordinate plane right here and we have a perfectly horizontal and a perfectly vertical, that we can just count the units. So if I'm looking right here and this is perfectly straight, I can just count from here all the way from G all the way to F. So I'm going to count 1, 2, 3, 4, 5, 6. So this is going to be 6 units. And when I count from F to E, I just count 1, 2, 3, 4, 5, 6, 7, 8. And that gives me 8 units. Alright, but now I get to this part right here, this diagonal, and I cannot count those, so now I have to go use my distance formula. So I gotta remember what my distance formula is, and I have distance equals the square root of, and we're gonna have x2 minus x1, and we are gonna square that, and we are gonna add it with y2 minus y1, and we are going to square that too, and this square root should be over the whole thing right there. Okay, so we are just going to label it. I will put this in red, maybe that'll be a little more clear. So I'm going to look at my coordinate down here, and I'm going to label this as x1, and this is going to be y1, and then up here this is going to be x2, and this is y2. And so I just take those points down and I plug them into my formula. So I have right here distance equals, and it's still under the square root, but let's have x2 is 3 minus negative 3, and I'm squaring that. I'm adding it with y2, which is 6 minus, and then y1 is negative 2, and I'm squaring that. And so I have a double negative. Let's turn that to a positive. So it's going to give me 3 plus 3 is 6. 6 squared. If you want to write it, 6 squared. And add this one up right here. This is going to be 8 squared. So this is going to give me 36 plus 64. Add those two together, and that's going to give me 100. But that is not my answer. Remember, this is all underneath the square root. I need to square root that. And if we were just thinking right here, if this side is 6 and this one is 8, does this long one really look like it should be 100 units? No. False. False. We need to square root it. The square root of 100, what times what equals 100 is 10. Yes, 10 seems a lot more reasonable. So I have 10 right here. I need to find the perimeter. So remember my perimeter, I'll put it right here. Perimeter is adding up all the sides. So I take 10 plus 8 plus 6. So 10 plus 8 is 18, plus 6 is going to give me 24, and then I can label it by just saying units. 24 units right there. And that is my answer. Alright, and then my last problem that I have right here is we're going to have problem, let's go black. Let's go problem number 4. So we did skip some problems, but a lot of them just had to do with finding the area and the perimeter, or the area of the circle, which we should have really good practice of that. And we'll make sure that we practice it even more in class, but this one might be a little bit more difficult. So we're going to make sure we write down the question. It says, what is the area of the figure at the right? All angles are right angles, and it gives us a picture right here. So in this picture, there are all different types of ways to solve it. I'm going to show you the way I like to solve it as far as breaking it down, but there are different ways to solve it. So the first thing that I would do is I see that these sides are congruent. I would cut this right here, and then I would cut this right here as well, and I see that all these sides are congruent. So this side is going to be 3, and this one is going to be 3, and we have the double line right here saying that's congruent with that one, so this side right here is going to be 9. Okay, so now that I have it cut down, I can find the area for each of these right here. So we have this side right here. If this side is 3, this side is 3, and this is a square. So to find the area of a square is base times height, or side squared. So 3 times 3, and this is going to give me 9. So I'm going to put that right inside. It's going to be the same thing for this one right down here, 9. But now I got to find the area for this bigger piece right here. Well, if the full thing is 9, and I'm taking away 3 of it, that means that right here, this is going to be 6. The same thing right here, if this full thing is 9, but we're taking away this 3, that means that this is going to be 6 right here. So to find the area of this square right here is side squared, or you can think about it base times height still. 6 times 6 is going to be 36. And just like our segment postulate, if I take all the area of each of these and combine them together, it's going to give me the area of that total shape. So I'm going to say that area right here equals 9 plus 9 plus 36. So area is going to equal, that's 18 plus 36. And so I'm going to get area is going to equal, and I add these up, that's going to be 54, and then I got to make sure that I label it. I have centimeters, and I am going to, anytime I do area, I am always squaring the units. I'm always squaring the units. So remember, the way I would say this is 54 squared centimeters right there. We got to make sure that when we're doing area that we square our units. So I would say this 54 square centimeters. Perfect. All right, sounds good. Thanks for watching. I'll see you next time.